How does a magnet pull iron without touching it? How does Earth hold the moon in orbit across thousands of kilometers of empty space? For centuries, physics had a massive problem with this. They called it action at a distance. It felt less like science and more like magic. But there is an invisible, silent network operating around us every single second. It's the reason your phone works, the reason lightning strikes, and the reason you don't fall through your chair. Welcome to the mind-bending reality of the electric field. To understand an electric field, we first have to understand what a field actually is in physics. Imagine a massive bowling ball placed in the middle of a trampoline. It warps the fabric around it, creating a dip. If you roll a marble nearby, it gets sucked into that dip. The marble isn't reacting to the bowling ball directly, it's reacting to the warped space around it. An electric charge does the exact same thing to the universe, but instead of warping gravity, it warps the electrical fabric of space. Electric field is simply a region of space around a charged particle where another charge will experience a force. If you are a charged particle, you don't need to touch another charge to feel it. You just have to step into its field. Since we can't see these fields with our eyes, physicists came up with a genius way to map them using electric field lines, and there's a universal rule for how they behave. By convention, field lines always show the direction a positive test charge would move. Because like charges repel, a positive test charge would run away from a positive source. So field lines always point away from positive charges. But opposites attract. That same positive test charge would fly straight toward a negative source. Therefore, field lines always point into negative charges. The closer the lines are to each other, the stronger the field, and the harder the pull. It's an elegant, mathematical map of pure invisible power. How do we calculate this strength? It's surprisingly simple. The electric field strength, E, is just the electrostatic force, F, experience per unit charge Q, it's measured in newtons per coulomb extend C. Look closely at this equation. The strength of the field depends entirely on the source charge, Q, and drops off dramatically the further away you get. Thanks to the radius squared or 2 in the denominator, double your distance, and the field strength drops to just 1/4. Every single piece of modern technology relies on manipulating these invisible fields. Inside your phone's processor, billions of transistors are constantly turning electric fields on and off to route data, creating the digital world you are looking at right now. The universe isn't just made of solid objects touching each other. It's an interconnected web of invisible forces. If you want to keep exploring the hidden physics that runs our universe, make sure to hit that subscribe button, leave a like, and tell me in the comments.